Cover proportions, starting chapter with proportions. Of all the things in math, I would think that proportions probably one of the most important things because there's so many different things that you can do with proportions and ratios, similarities. It can fit into so many different occupations, and it doesn't have to be, like building something or something. It could be just about anything. I know I used to work at a convenience store, and I used this stuff all the time when I was older. All right, so proportions very, very important, and most of you should know a lot of the proportions or a lot of the stuff that we're going to cover this chapter, but we will get into new stuff. Somebody last block said, "Well, why are we doing the easy stuff now and we did the hard stuff before?" Well, because what we're going to do with it, you had to know things about triangles and different things before you could actually do this. So what we're going to do, be able to find ratios, set up ratios, be able to solve proportions, set up and solve proportions using the geometry stuff that we've been doing. All right, these ratios. A ratio is a comparison between two quantities. Write that down. That's what a ratio is. Ratio is a comparison between any two quantities. Could be comparing apples to oranges, feet to inches, feet to seconds squared. So that's a ratio. When you write ratios, do you Ratios can be written three different ways. Please, when you write this ratio, I'm going to get rid of this one. Use a fraction bar, not a slash. Anytime you write ratios or proportions, I don't understand why you call it that. Because, especially when I get into proportions, if I write this, does that make it harder to do the math? Because what do you do to solve a proportion? You cross multiply. Can I cross multiply with them written that way? No. It's plus, when you start using fractions with variables, and when you get into higher level math, you'll see it. But if let's say I have 2/3 x, and if I write it this way, it looks like that x goes with the what? It looks like it's 3x on bottom, right? And that's not what you want. So you got to be really, really careful. Different ways to write ratios. One that we'll use most of the time is a fraction. Using a colon's another way. Using the word two is another way. So make sure you know all three of those. And know if they tell you there's 5 cows to 6 pigs, then that could be written 5/6 so that we could do mathematical stuff with it. So we have to switch from one form to the other. And again, this is the one we use most of the time. This one's probably the one that we should use most of the time, but it confuses people, so we don't things I want you to write down. A proportion. I can never get my pen to work again. Write down proportion. And I'm just going to give you the definition of it. Somehow a slide got misplaced on my slideshow here. A proportion sets two ratios sets two ratios equal to each other. It's just too close to the thing up there. So sets two ratios equal to each other. That's all a proportion is. Also write this down. Whenever you have a proportion, and this is probably new, so most of you probably haven't heard this before. In a proportion, you have four different terms. First term or first spot, second term, third term, fourth term. I'm going to write another one over here just using some letters. So A in this case is in the first location, B is in the second location, C is in the third location, D is in the fourth location. Another way we could write these, using the colon, A colon B equals C colon D. Anybody have a guess? Which ones do you think? Which ones do you think are the extremes? Looking at this right here, what's extreme mean? Sort of. Extreme, what's extreme mean? Alright, so which of these letters do you think are the extremes? There's two of them.
B and D.
Like six different. How come A and D? A and D are your extremes. So which terms are A and D? Does that make sense? The first term and the fourth term, those are the outside ones, and that's what extreme means, right? Outside the normal. So first and fourth terms are your extremes. First and fourth terms are the extremes. What's the word mean? Average, maybe, but see, that's what some other teacher taught you, but mean's not really an average, because there's all kinds of things that are averages. If you're looking for the mean of a set of numbers, where are you looking at in that set of numbers? In the middle, and that's what the mean tells you. So which of these do you think are the means? B and C. Second and third terms. When you solve a proportion, what do you do? How do you solve a proportion? Cross multiply. Everybody, you all know that, right? Something we've done for probably 4 or 5 years now. 4th, 5th grade, somewhere around there maybe. You cross multiply. Well, your teacher taught you to cross multiply. You know, they probably taught you to draw that little bubble around that side, draw a little bubble around this side, or maybe they showed you just to put the little lines in there to show which ones you're cross multiplying. The actual mathematical thing that you're doing, we're multiplying the first and fourth terms. Well, what are the first and fourth terms? The extremes. So multiply extremes. And that should equal what? multiplying, what you're actually doing is multiplying the extremes on one side, multiplying the means on the other side, and setting the two equal to each other. So again, that's probably new, extremes and means. You gotta know that because we're gonna do some stuff later on with the means, different kind of means in math. We're gonna talk about that later on in the chapter, in the next chapter also. Write these three down. We're gonna solve these really, really quick. And yes, Josh can probably do a lot of them in his head. The problem is when you get to one like number 3, he can't do it in his head. And then when we get to some of the other stuff, and I know that a lot of you can probably do it in your head, but Josh is going to watch closely, even though he thinks, oh, I know all this stuff. I don't want to touch your head, just like I don't care. So he wants to watch closely because when we get to the harder stuff, even though this one he can probably figure out in his head, most of them that we're going to do in here are going to be like this? Probably not. They're probably going to be the harder ones. So when we get to those harder ones, make sure you're paying close attention. How do you solve this first one? Cross multiply. I gotten lazy over the years, so I don't do the bubbles anymore. I just do the little lines. So that's 3 times x or 3x. That's our extremes, right? Extremes multiply times each other. Means times each other, right? Instead of 60. Divide by 3. X equals 20. Some of them now later on in the chapter when we're setting up stuff on your own, pairing up similar triangles or similar shapes, they will be that simple. But the bad thing is that you have to set them up first. I forgot to throw my line in there for that one. What's our extremes this time on number 2? X and 20, so I'm going to write 20x. What's our means this time? 11 and 15. Everybody do 11 times 15 in their head? 165. Do 10 times 15. What's 10 times 15? 150. Add another 15 to it. 165. This is going to be a little different too. Josh couldn't do this in his head because it didn't come out even. You end up with x equals, how many 20s are there in 165? How many whole 20s? 8. How many left over out of that? How many left over out of that? 5. So it'd be 5 out of 20, which reduces down to 1/4 or 0.25. I'm going to use 1/4. That makes sense, Brian?
Yeah, makes sense.
Why would you write 0.25 when you write 1/4?
Because fractions.
On this next one, watch closely on this next one. Anytime you see something that looks like this, what's different about this one from the first 2? Not an equation, it has a expression, right?
Yeah.
Now it has more than one term up here. Anytime you see something like that, do this very first thing. That's the key. Put parentheses around it. No matter where it's at, whether it's in the first spot, second spot, third spot, fourth spot, if it's got more than one thing in there, put parentheses around it. Now when I cross multiply it, I'm going to write it this way. 2 times parentheses 3x minus 5. And then on the other side, what do I have? What's my means this time? 4 and negative 13. What is 4 times negative 13? I'll give you this part. I know it's going to be a negative. 52. Good. What do we do to start to solve this? Distribute. What's 2 times 3x? 2 times negative 5? Negative 52. Add 10 to sides. I'm running out of space down there, so I'm gonna move up here. These cancel, 6x equals negative 42, and what? So what's x? Close. Negative 7. Is it alright for x to be a negative 7? Yeah, now later on in the chapter when we're looking for the side of a triangle or something, probably won't be alright for x to be a negative 7. So when we get to that, we'll decide. A hockey player scored 9 goals in 12 games. Find the ratio of goals to games. Probably not realistic as far as the goals go.
9 goals in 12 games?
If it said, not for a professional.
Yeah, it is.
If it said,
A good hockey game is like 2 to 3.
if it said points, maybe.
No, there's a difference. There's like various points in hockey. I don't know what it is. Players get like 81 points or something.
Right, and so that's what I'm saying. The way this works out, a normal hockey player, even real good hockey players, this is a sort of high ratio for even a real good hockey player. Even Wayne Gretzky, yeah. But if you go by points, which points include assists and goals, then it's more feasible.
I can never figure out points. I always feel like
That's when you just
Exactly.
Google it.
I don't know, man. Sidney Crosby,
I get it.
I bet he could do that.
What are we comparing here?
Goals to games.
Goals to games. Might help sometimes to write it down like this. So what's going to go on top? What number? 9. What on bottom? Now, do you leave it that way? What do you do to it? Reduce it down? 3/4. Now, somebody explain this number to me. What's that 3/4 mean? He gets 3 goals. He's going to score 3 goals every 4 games. All right. So if I told you something like, "Hey, this guy played 40 games," how many goals would you expect that he scored? 30. All right. And we could set up a proportion. 3/4 equals something over 40. How many games are there in a professional hockey season? Like 68 or something like that? So we could set up, if this is a professional guy, I think there's 68 somewhere around there. I don't know, they change it all the time. So we could set that up and solve that way. It'd be a little harder. We'd have to actually do the math. But this was the answer to the question. We didn't want to press that stuff. That was just extra. Can you see that? X minus 2 over 2 equals 4/5. I'll tell you what, let's skip that one. Write this one down. We did problems like this one and the next one after, on the next slide, earlier this year. I thought we had to do something special with it. We didn't do very many of them, and now we're going to do a lot more of them. anytime you see this, we talked about this earlier this year. Does that mean that this triangle, that this side's 9, this side's 8, and this side's 7? No. What do you have to do with each of those numbers? Anybody remember that? Instead of this side being just 9 units long, what do we put with that? Put a variable with it. So anytime you see something written this way, or it's got more than 2, so you can't just set up this over this, always put a variable with each number. Put a variable with each one. Sorry. So how long is this side going to be? 8x. How long is this side going to be? 7x. Now, set up my equation. I do 7x plus 8x plus 9x equals 180, right? Oh. Brighton, I'm going to throw something. It equals 140. Don't do that. Please make sure. We've said this several times.
144.
3 sides, 144 yet. 3 sides of a triangle, do they add up to be 180? No. What adds up to be 180? 3 angles. So when I set up this equation, I'm going to say 7x plus 8x plus 9x equals 144 equals the perimeter, the whole distance around it. How many x's do I have here? Don't say 3. 24?
Yeah, 3 written down.
Brian, you've been doing well. Don't. And when I say, when it says find x, don't do this either. Hey, it's right there. Yeah, that's funny like once. Now how do I?
X equals 6.
X equals 6. Everybody agree with Brian? Yes.
No.
Now x equals 6. Is that our answer? What do they want us to find? Find each side. So we got to go back to each one of these. What's 7 times 6? 42. What's 8 times 6? What's 8 times 6? 48. And 9 times 6? 54. Those are your 3 answers. You could check it. How could you check it? Add them up, and they should add up to equal 144. If they don't, then we did something wrong. Right. Somebody else must have done this easy. If they put something on there that shouldn't be on there, then it wouldn't be. It says stunned. Usually if I hear something on there that I don't think is appropriate, I'll take it off, but a lot of times, like I said, I have the students put them on there and I can't tell the difference. I will give back your test. I won't let you keep them though, because we're going to do something with them. All right, on this one, the ratio of the measures of 3 angles of a triangle is 5 to 7 to 8. Again, see that? What do you do with each of those numbers?
Put an X on.
Put a variable with it. Good. What equation can we set up from that? Let's write it out so that 5x plus 7x plus 8x. This time we are talking about the angles of a triangle. What do you know about the 3 angles of a triangle?
Yeah.
We have to add up to equal 180. How many x's do we have there? 20 equals 180. Divide by 20, what's x? 9. Is that our answer? No, they want the angles, right? So we go back and we plug in. What's 5 times 9? 45 degrees. What last one, a little tougher on this one. This one, you might wanna write down, some of you chickened out on the bonus on the test.
That was tough, dude.
This right here will show you how to do it again. Put parentheses around those two things, cause they have more than one term in each position. When I rewrite it, 3x minus one times x plus two. What's on the other side when I multiply the means? Negative 4. Writing was correct. What do you gotta do first here? This is gonna seem like a lot of work, because we can't have this negative 4 over there. To factor and solve, like the stuff that was on the E-Day and all that other stuff that we've been doing, this over here has to be a zero. So what we gotta do first, I think Brian said this, FOIL. You gotta undo all this, move that 4 over, then redo all the factoring. Well, FOIL, what's FOIL stand for?
First I recognized.
It's 3x times x. 3x squared, that's first terms. Outer terms, what's 3x times 2? 6x. Inner terms, what's negative 1 times x? Negative 1x, good. And last terms, what's negative 1 times 2? Negative 2, that still equals negative 4 over there. We can collect these like terms in the middle here. End up with 3x squared. What's 6x minus 1x? 5x. Got the minus 2. Alright, you're gonna move the 4 over. If you want to do that in the same step, that'd be alright. Move that 4 over, you make it a plus 4, so what's that give you? Plus 2. All that equals 0. That's what you wanted. You want 0 on that side whenever you're doing quadratics. Now you set up your parentheses. You find the factors of the first term. 3x squared. What are the factors of 3x squared? What times what will give you 3x squared? 3x and x. Those are the only ones. Messed up on it. So we put 3x there, x there.
What's the thing I was up above?
Sort of. But now it's gonna be a little different. We gotta find the factors of positive 2. Unlike on the E-Day, since our leading coefficient was 3 and not 1, the only way we can do this is guess and check. The lucky thing here is, what are the factors of positive 2? 2 and 1, or it could be negative 2, negative 1, right? But since everything in here is positive, which one do you think it's probably going to be? Probably the positive one. Now here's where it's going to be different. You want to put the 2 first or the 2 second? First? Second?
Said different, so I said second.
Put it in this way. If I put it in that way, plus 2, plus 1. How do I know if I factored it correctly? Go back to FOIL, to check it. This is where you had to guess and check when you were factoring. Just do the outer and the inner. What's 3x times 1? 3x. What's 2 times x? Those two should combine together to give you the middle term. Do they this time? So we factored it correctly. If you put the 2 over here and the 1 over here, it would have been 6x plus 1x, and that gives you 7x, and that wouldn't have been right. Now, once we're to that point, how do we solve that? Set it up equal to 0, right? So the first equation is going to be what? 3x plus 2 equals 0. How do I solve that? Minus 2. 3x equals negative 2. Then what? 5 by 3. So what's x? Negative 2 over 3. That's one of the answers. 1 equals 0. This one doesn't take as much to solve. What do you do there? Subtract 1, we end up with x equals what? -1.
What is the longest problem?
Those are our two problems. Now, Peyton's saying it's the longest problem ever. Do you think it took me that long to do it if I was doing it? So once you learn it, is it going to take you that long to do it? No.
Oh, I can feel.
Oh, dude, that is so inconvenient.
Make sure you write this down. Along with this, the other part of your assignment, Chapter 5 test,